Hello, in this video I'll show you how to find angles without your calculator for some special ratios. So if you look here, square root of 2 over 2, 1 over 2, square root of 3, hopefully these are ringing a bell for you, that you're thinking, oh, these are numbers that I saw earlier when I had a 45, 45, 90 triangle, or when I had a 30, 60, 90 triangle. And you're exactly right, they are. Couple ways, just practicing and getting familiar with it, you might be able to just look at a number 18 and say, oh, alpha is a 45-degree angle. But if not, just remember this is opposite over hypotenuse. Make yourself a triangle, put alpha in it. Opposite side is square root of 2, hypotenuse is 2, and we need to find the angle here. So maybe if I knew what x was, that would help us out. So if I take x squared plus the square root of 2 squared equals 2 squared. If I'm squaring a square root of 2, I'm just going to end up back to where I started at 2. Gives me 4. Subtract 2 from both sides. X equals the square root of 2. This is interesting. Do you see here? This side is the square root of 2. This side's the square root of 2. What do you think that means alpha is? If these two are the same, it has to be a 45-degree angle. And so alpha equals 45 degrees. Go ahead and try 19 and 20. Pause the video. For the next one, I'm going to set up a triangle. I shouldn't draw it because I already know the answer. If I just draw a random triangle without knowing what it's going to look like, actually that would have been an okay picture. But if alpha here, adjacent side is next to the angle, I get 1, hypotenuse is 2. Pythagorean theorem now, 1 squared plus x squared equals 2 squared. 1 plus x squared equals 4, x squared equals 3, x equals the square root of 3. And now this is the square root of 3. And now I don't like this picture. I want to redraw it so it is more drawn to scale, because that's going to help me know where to put my angles. You can think it through. We can see, okay, this is 1, 2, square root of 3. That's good. We know that is going to be a 30, 60, 90 triangle. The 60, 30, 1, 2, square root of 3. And now I could see my 1 is here, my 2 is here. 30 and 1 are opposite. 60, square root of 3 are opposite. So long story short, what is alpha? Alpha has to be 60 degrees. And so for 19, alpha equals 60 degrees. All right. Cotangent. Oops, didn't want to do that. What do I want to do? I think I'm just going to do number 20. We'll do it over here. All right. So I've got a triangle. I know alpha's here. Cotangent is the reciprocal of tangent, so instead of opposite over adjacent, it's adjacent over opposite. We know the adjacent side is square root of 3. What's the opposite side? Hopefully you're thinking you can just put this over 1. And now we're set. Square root of 3 squared plus 1 squared equals x squared. Kind of ran that together. Doing the Pythagorean theorem here. It's going to be 3 plus 1 equals x squared. 4 equals x squared. Probably not surprised. You probably saw it coming up here, right? That x is 2. So if you can skip this, that's fine. You can skip straight to here. Alpha, though, is at 30 or 60. Well, if you know your triangles well, you'll remember that 1 is opposite the 30-degree angle. If not, I would encourage you to go ahead and draw it. This is 1.73. It's going to be longer than 1. 1, 2, square root of 3. Hopefully this helps you to see that this is 30 here. So in this case, alpha is 30 degrees. So in this video, we took a look and we saw how when we have some ratios, we can work backwards to build the triangle to find the angles. Now, this won't happen for all ratios, but if it says find the exact acute angle, that's probably what they're getting at. Now, some of you are saying, well, I could just put that in my calculator, right? If sine alpha is the square root of 2 over 2, I can solve this by taking the inverse sine of both sides, and in my calculator, just typing in inverse sine of square root of 2 over 2. And you are exactly right. Type that into your calculator. If you're in the degree mode, it will tell you your final answer is 45. Now, you might say, well, that's a lot easier. I don't have to do all this thinking. Here's the issue. This thinking has a lot of the fundamental ideas we're interested in. And so if you're doing this, it's really going to set you up nicely and help you down the road. If you do this, you're kind of shortcutting yourself from the learning that happens here. But that's your call.